So, back in the day when we started multiplying powers, 2 to the 3 times 2 to the 7, we added the exponents, right? So if I were to just talk about the exponent, right? The exponent of 2/3 times times 2/7, right? The total exponent of that would be 3 plus 7, correct? So if I were to ask you, what is the exponent of 2/3 times 2/7, you would say 10, right? You would just add the 3 and the 7. And so let's go to some of the properties here then. Because logarithms are just exponents, then we can use those properties to, write, stuff further for our exponents. The first thing we talk about is the product property of logarithms. And it says if you have positive numbers m and n and b, if you have log base b, m times n, that's equal to log of m plus log of n. Okay, what does that mean? So this is telling you the total exponents of the stuff multiplied to each other is equal to the exponent of the first plus the exponent of the second. Isn't that exactly what we did? And the total exponent would just be 10. Okay, so that's where that comes from. Usually we just tell students, memorize this, but of course in my honors classes, we want to know where everything comes from. Okay, so if you take a look here, right, this is exactly what we did. So this is log base 2, 8 is 2 cubed, 4 is 2 squared, okay? So again, this is the total exponent here. Well, that's the same as the exponent of just this plus the exponent of just this, right? And so here, the total exponents here is 5. The exponent here is 3. The exponent here is 2. So 5 does equal 3 plus 2, right? That's sort of where the property comes from. Okay, let's take a look at this one. Yep. Oh, that's it. I mean, we're not really solving. We're just exploring. We're just doing what I did again. Yeah.
Is it 5 because it's 2 cubed times 2 squares?
Right.
The exponent.
Okay. So here, log base 3 of 2. So you're just told this value, like somebody plugged it in their calculator and it's 0.6310. Log base 3 of 7, again, that's the value. And we're going to use that to evaluate log base 3 of 14. Well, what is log base 3 of 14? We're going to write it in terms of a 2 and a 7. So notice log base 3 of 14. The 14 can just be written as 2 times 7, right? So now I have a logarithm of one thing times another thing. Well, using the property, I say this is equal to log base 3 of 2 plus log base 3 of 7. And then I just substitute the values, 0.6310, 1.7712, and that gives you this, okay? And now you might say, well, wait, couldn't I have just plugged this into the calculator? That's not really the point. The point isn't this final, 2.4022. The point is the first 2 steps here, right? How to expand that. Okay, so the quotient property is the same. So now when you're dividing powers, what do you do to the exponents? You subtract them. So here, if you have log base b, m over n, it'll be log of m minus log of n. Okay? So here, I have log of 3 given to me, log of 7 given to me. How can I rewrite that? What would I do? It's log base 2 of the first one. Then what do? Minus log base 2 of 3. So remember, division goes to subtraction. multiplication to addition. It's just like, just remember exponents. So this is going to be 2.807 minus 1.585, 1.222. Okay, so the next thing, the third property of logarithms is the power property. So basically, if you have log base b of m to the power of something, that exponent comes down and becomes a coefficient of it all. Okay? So, let's take a look at this one. Now we're going to have log of 3, log of 7. Now I have log of 36, which I need to break down, and I need to be able to write it in terms of a 3 and or a 7. Okay? So let's see how 36 gets broken down. 36 is 4 times 9. Okay, which is 2, 2, and 3, 3, right? Huh? Huh? Okay. Sorry. Log base 2 of 2 to the 4, 2 squared, times 3 squared. So take a look at what I did. I just rewrote the 36 as 2 squared and 3 squared. Yeah? Now we're going to expand. This is going to be log base 2 of 2 squared. Then what? Plus, minus, times, divided by. Which one? Plus log base 2, 3 squared. Okay. So this 2 will move down here. So you have 2 times, what's the rest? Log base 2 of 2, which is what? You're sure?
No.
1. Okay. And then this 2 will also move down, so I have 2 log base 2 of 3. So this is 2 times 1 plus 2 times 1.585, and that's 5.17. Okay, are we all comfortable with log base 2 of 2 equal to 1? The exponent of 2 that gives you a 2 is 1. Okay? Okay. Ooh, let's do the next one. Yeah.
That was 2 times log of 2, but that was that 1.
So it's not. Just this is 1.
How is it 1?
Well, what's the base?
2.
What should be the exponent of 2 to get a 2?
Oh.
Right.
So you don't need to use all of what's provided.
No, you don't need to use all of what's provided.
You at least need to use one though.
Right. You're probably going to have to use 1. So look at that one. So we have a 3, we have a 7. Whenever you have a decimal like this, I would write it as a fraction. So here we're going to get log base 2. 3 over 4, right? That's 0.75. So this is going to be log base 2 of 3 minus log base 2 of 4. Okay, that's the number we're given, 1.585, minus, how much is this? It's
2 squared.
It's 2 squared, so it's just 2. Right? So the exponent of 2 to get a 4 is 2. Yeah? And then this will be negative 0.415.
Wait, how did you get 2 for log?
So the base is 2. What should be the
Yeah.
It's a whole new like world.
Keep
So
forgetting, yeah.
just think exponents. Yes. Okay. Questions?
So what's P?
Huh?
I don't really get the P part.
What P?
Like equals P times log Pn.
Oh, so that just says here, remember how we had an exponent here? Whenever you have an exponent, it comes down and becomes a coefficient. Now in this case, there didn't happen to be any exponent, so it didn't apply to this. This property just says if you have log base 2 of 2 or something, and there's another exponent, the exponent moves down and becomes a coefficient.
Oh, yeah, yeah.
Yeah.
Why does it give you log base 2 instead?
So this is extra information. I actually think like at some point I had a third problem in here, but then I was like, okay, I think, this is enough. So I just, yeah. Okay. So solve each equation. Okay. So to solve the equation, remember what we were doing before was if you have identical logarithms on both sides, you can set the stuff inside equal to each other. Well, here, take a look. I have log base 5m. Here, the 1/3 is kind of getting in the way. I kind of have to get rid of that. So I'm going to use that product property in reverse. What I'm going to do is I'm going to take this and make it an exponent. So that can always like fluctuate back and forth. Yes? So now I get log base 5 of m is equal to log base 5, 125 to the power of 1/3. So now we can set inside stuff equal to each other, which means m is just cube root of 125, so it's just 5. Questions? Okay, ooh, what about this one? So this one here is another issue because now I have more than one log on each side. You should only ever have one logarithm on each side of the equation. So what we're going to do is we're going to condense them. Okay, so remember how, so we're going to go backwards now, right? So remember how the coefficients can become exponents? Okay, this will be log base 3 y squared plus log base 3 0.1 equal to log base 3 of 5 plus log base 3 of 2. Okay, now when we have two things that were multiplying inside a log, we can separate them as log of one plus log of another. But we can also go in reverse direction. So if I have log of something plus log of something else, I condense it and I multiply the insides. So take a look at what we're going to do here. This is going to be log base 3 y squared times 0.1 equal to log base 3 5 times 2. Now I can set the insides equal to each other. So I get 0.1 y squared equal to 10. What happens if I divide 10 by 0.1? It's 100. Y squared is 100. So what's y? Just 10? Plus or minus 10. Okay, do both of them work for this?
What?
Plus or minus 10?
No,
Not the negative one. Okay, so y is just positive 10. Okay, negative does not work. Okay, let's do another one. Let's condense this. Okay, let's condense this. Log base 7m equal to. Okay, this is gonna look, we're gonna see if we can do this in one step. These are all gonna be coefficients, right? I'm sorry, exponents. When I condense this, I'm gonna have one logarithm. So this 64 blah blah and the 121 blah blah, are they gonna be multiplied or divided? Multiplied. So it's gonna be 64 to the 1/3, 121 to the 1/2. Okay, so m equals, what's the cube root of 64 these days? 4. What about 11? So 44. Okay, isn't this fun? Yeah. Okay. Oh,
We get to the text,
So M equals
it's gonna be
44.
like,
m equals
And
44.
then also, like, negatives never work, right?
Well, if you plug it into the logarithm and it's still a negative, it doesn't work.
Oh,
But
okay.
if you have like log of x squared, that's fine, right?
Yeah.
Okay, so here, what's going to happen to this log? We're going to condense it, so we're going to get log base 6 of what? X times x plus 5 equal to 2. Okay, what is different about this equation compared to all the other ones?
There's no log on the other side.
There's no log on the other side. If there's only one logarithm, then what do? Oh, leave it. No, we gotta solve it.
16 power 2.
Yes, good. So now you say, oh yeah, that's an exponent. Every exponent needs a base. That's the base. So we say x times x plus 5 is equal to 6 squared. Yeah? So x squared plus 5x minus 36 is equal to 0. Is that able to factor? Yeah? Of course, yes. Look at how nicely it factors. 9 and negative 4. So x is negative 9. X is 4.
It's just 4.
It's just 4. So let's just see. Does 4 work? So here you get x equals, so log of 4, and then log of 9, right? That actually does work, because it'll be log base 6. So yes, it does work. Okay. Yep.
I'm pretty sure you got it to be 6 squared.
So when you have a logarithm of something equal to a number, then you use the property that a logarithm equals an exponent. So this number is always the exponent. Every exponent needs a base. So where's the base?
Okay.
Here. Okay. So this one we're going to condense. But we have a minus this time. So this 4 is going to become an exponent. So we're going to get log base 2. X to the 4, right? But what's going to happen to the 5? Is it going to multiply or divide? Divide. So over 5 equal to this. Because there is a minus here. Minus means divide. So now I can set the insides equal to each other. Okay. Okay, so so this is going to be x to the 4 equal to 625. How can I solve this? Fourth root. And x is 5. Yay. Okay, what about the next one? What happens here? Log base 7 of x squared is equal to log base 7 of what? You multiply them, but now look. Don't multiply them just yet. Don't multiply them out. Just write them like that as a product. Because now x squared is equal to 27 times 81, right? But now look, I'm going to take a square root of this, aren't I? Which means what's going to happen? X is plus or minus 3 times 9. Right? Each of them comes out as the square root, right? So, root,
27 is root 27.
oh, that's a 3 root 3. Oh my God, Miss Malikian, you guys didn't see that.
So what do you do?
So it's okay. So it's 3 root 3 times 9, which is, come on, which is plus or minus 27 root 3, but of course the negative doesn't work, so x is 27 root 3. Okay, so don't just automatically reach for your calculator and multiply these out, right? Like, think ahead. Oh, I have an x squared, I'm gonna have to take a square root. Okay, so let me just wait until I multiply everything out. Yeah? Yes.
Isn't it 20? Why won't you multiply up to 7 and 8? Why won't you multiply that?
Because then you're going to get too big a number, and this could actually be on a non-calculator section, so you don't want to do that, right? But in Algebra 2 Honors, you're expected to be able to do this without a calculator. Yeah. Okay, so...
Would it be like a 3 root 3 if it's no calculator?
Yeah. You can do that. You're in Algebra 2 Honors. You can do this. Yeah. Okay. So we talked about population for, exponential stuff. When we came to logarithms, we talked about the Richter scale as an application of logarithms. Here's another application of logarithms, and it's pH in chemistry. So the pH, of something is like 1 to 14, right? The acidity level between acidic and basic. The scale ranges from 1 to 14. Well, those numbers, 1, 2, 3, 4, up to 14, just like the magnitude of an earthquake, 1, 2, 3, 4, those are a logarithmic scale, right? So pH is actually negative log base 10 of this. What that means is the high concentration of hydronium ions, right? The H plus ions. So this is the concentration of H plus ions, right, in the bracket. Okay, so the logarithm of and the concentration will be in like thousands, right? So we take log base 10 of 10,000. Oh, the pH is 4. Isn't that cute, right? Okay. And okay, so there's going to be a negative. So look, if you have a negative out here, that is a coefficient. When you make it an exponent, it'll be the concentration to the power of -1, which means it will be 1 over the concentration. Do you see that? Okay, awesome, good. So what is the pH of a solution whose hydrogen ion concentration is 6.3 times 10 to the negative 3 moles per liter? Well, pH, no, the negative is before. So hang on. Okay, so negative log base 10, 6.3 times 10 to the negative 3. Okay, so take a look at what we're going to do. You should be able to expand this. This is negative outside. Log base 10 of 6.3 plus log base 10, 10 to the negative 3. Okay, so this is negative. This, when you plug into the calculator, it's 0.779. Okay, this, the negative 3 can move down, right? And then what happens to log 10 of 10? How much is that? 1. So this is still negative 3 times 1. So, okay, so you have log base 10, 10 to the negative 3. Negative 3 moves down, so I have negative 3 log base 10 of 10. So this is negative 3, and then all that is just 1. Right? Okay.
Oh, so then you get negative 3, but then how do you get the points?
Right. Huh?
How do you get the points?
That we plugged in the calculator. So this will be 2.2.
But 0.779 is
Log base 10 of 6.3. So that's like the only thing you would have to plug in the calculator. However, if this was just like, without the number log base 10 of whatever, you should be able to do it by hand. Okay. Now, what is the hydrogen ion concentration of a solution whose pH is 8.5? So pH, the formula is, it's negative log base 10 of this. So that is what we're solving for, okay? So this is going to be 8.5 equal to negative log base 10 of H plus ions concentration. Move the negative over. Okay, so how much is the H plus concentration?
It's 10 to
10 to
the power.
the power of. So remember, this is now an exponent. Every exponent needs a base. What's the base? 10 to the power of negative 8.5. Okay, and that's good enough. You could just leave your answer like that. Because that's, you know. Okay? All right, so that's that.